So I'm Thorsten, I work for NodeSource, and I want to talk to you about Node assembly. All right, so basically what happened, Node 12 is kind of out the door. It's kind of behind the door. It's about to knock. It's going to come in, and it has kind of some new features because it's using a newer version of V8. And V8, that new version, it actually added some more support for tools that want to consume JIT information. I'm going to talk about JIT in a second. And there are some tools like debuggers, like GDB and LLDB, that are actually able to use this information. However, they're still kind of catching up, and because this is all kind of still new. But the thing is that we can write our own tools. So I did. So I'm going to get to a demo right away. So imagine this scenario. You are, so let me make this big enough. Okay, so let's just say you're in a situation where someone, you wrote the server and you're using a bunch of libraries, and you start realizing that the server is kind of slow. So you are trying to figure out who is calling a synchronous file read, right? So now you could go grab through your code, try to look for FSB file sync, but there could be other ways that I can cause a synchronous read. I could just require things, in line when a request comes in all the time, and if it's not in the cache yet, it will also trigger a file read sync. So what we can do though, we can figure this thing out on the C level. So what we can actually do is we can actually launch this debugger, LLDB. Who has heard of LLDB? Who has used LLDB? All right. So we can use a debugger, and here I have this latest version of Node installed, and I'm running the debug build, so it doesn't inline my functions. And then I give it this this flag, and that will basically cause files to be written here. So let me actually clean that up. All right, and so this will all make sense when the demo goes through. So now I'm basically just launched my Node process, but it didn't run it yet. I basically launched LLDB and I said debug this process, give it these flags, and so on, right? And now what I can do, I can set a breakpoint at UV. I can say the name is UV fs read, and I can say the condition is when the callback is null. Right, and that basically when you're calling a synchronous file read, the callback pass to the BV, or this function here, is actually null. That's how I know that it's synchronous. Because if it was asynchronous, I'd need a caller, obviously. So now I set a breakpoint, and I can list my breakpoints here, and you can see I got a breakpoint here, and the condition is callback is null. And now I can launch my process. And now obviously I'm going to hit this a few times, right? Because we are requiring modules at this point, right? So now we're going to have some synchronous file reads, but that's okay. So now I'm listening. And do we all agree that while my server is running, there should be no more synchronous file reads, right? It's like a bad thing. We don't want to do that. So, but anyways, if I curl to my server, ls, I hit my breakpoint. There was a synchronous file read. Okay, so what we can do, we can look at the backtrace. That's kind of interesting. Let me actually show this a little bigger. So we see like a bunch of things in here. And does anyone want to guess what this is? This is actually JavaScript, except it's now assembly, and we don't know anymore what it really is. What we can do, we can copy this information. Okay. And copy this tile trace, right? And then going over here, we don't need this anymore. And now this perf map file was generated here, right? And don't worry, I'm going to go into more detail with that. But basically now what I can do is I can just kind of with SB, all this does, it just prints what's in my clipboard, right? But I can pipe that through a tool that I wrote called resolve JIT symbols, and I give it this map file, And alas, we have JavaScript. Right? So now all these symbols that were only known to be some addresses somewhere, they got now actually resolved to that JavaScript that was the origin for that assembly that was generated. Does it make sense to everyone? Right, don't want to lose you halfway. But the thing is, it looks kind of crappy, right? But in true Unix style, we can write us another tool that makes it pretty. Okay, now it looks better. Okay, so now we can kind of see what's going on here, right? We got a bunch of these. The only thing is that kind of, you see streamreadable.js, but you know, it's just a file, so we don't really know where it is yet, but we can fix that too. We can pipe it through trans, which stands for trace enhance, and and we can give it the node dir, right? Because we know we're running, as you saw, it didn't run just any node. I actually had cloned node, and you know, all the source code is there. So we can tell it where our node dir is, and then it will basically help us resolve these symbols. So now do that, and at this point now, we have all these texts. So now I can say, okay, so it was reading a chunk. I can now actually click on that, and let me go to that one. And yay, it's right on the line where the readable chunk is defined. So now I can backtrack what's going on, right? Like what kind of JavaScript is actually running that caused this my synchronous file read to happen. So if you scroll a little up, right, we can kind of see like this is a FS read sync right here, and what caused it is somewhere here, and we can basically, the idea is that we can backtrack and find the culprit. Scroll a little more down. It's a lot of information, but basically somewhere here we have that, right? So this was a function on request. Oh look, we found the culprit. Yay. FSV file sync. Right, that's how quickly I found it. Like, I mean, you could have searched your entire JavaScript code and tried to figure it out, but this one actually told us, like from the C level, we could backtrace all the way back to this function that actually caused this to happen. Right? Does that make sense? Okay. So now, but this is not good enough. Like, I don't want to like necessarily click on files, right? We have the source code, so we can say, can you please include like the source line, one above and one after also. So now I can do that, and now it's running. And now for every trace, I have to tell it to also include the code, -c. For every trace, it will now include code. So there you go. Now you can actually look through things, and it will basically tell you, so on read was here, and you can like include as many as you want. It's kind of like grep. You can like say include this many lines above and this many lines below. And this is like a great debugging tool if you kind of have a problem like this, like because you know the connection to C back to JavaScript is not obvious if you can't figure out what these symbols are, right? So this actually helps you a ton, and we're going to show more another example where this becomes useful. All right, so let's go back to the slides. We're going to just like hash through the demo to make sure that you actually understand what went on. So we did start the LDB debugger, and we gave it these, you know, this node that we had installed, and gave it this -perf basic prof, and that's important because that's what makes V8 put that map file at the temp folder. And that's pretty much it. And when we run it, the process will start. We could break into it, and then we can end the breakpoint afterwards. Once we have the breakpoint, we keep running our server, we go to our server, right? And then if we hit our breakpoint, we know while our server is actually handling requests, we're getting synchronous file reads, right? Which is bad. And then we basically, here we have our requests, we have our frames. And so now I'm going to talk a little bit about how I actually map these addresses back to symbols, right? Because I told you there's this weird map file. And basically what it has, it just has basically addresses in it. and the size, and then the symbol that is defined at that address, right? So, or which was basically V8 for this code, for this function, it generated assembly starting at this address, right? So now if you give me an address, I can look through here and I just have to find it in between two addresses, right, that are mapped. And then I know the one before must be that symbol, right? And that's basically how we can figure that out. And the perf tool on Linux actually does the same thing. When you run perf and after you're done, you run perf script, it will actually look for that map file and it will map your symbols like that. I think the term is symbolicate, pretty sure. So then what we did, we copied that stack trace and then we piped it into resolve JIT symbols and we gave it that map file. So resolve JIT symbols knows what map file to use to symbolicate our stack trace. And that's pretty much it. And all this is open source and online, so you can use it. And then we basically just piped it more to pretty trace, and it's like Max is a big fan of Unix. I'm also a big fan. So we pipe things. By the way, you can also do this online. If you don't like the terminal, I also created a web app, and my wife actually started to make it pretty. And you can actually load things in there. And so we're going to show the same demo again, except this time we're going to use no terminal. Because we can also use Xcode. Who has used Xcode before? So Xcode is actually this kind of really nice thing that Mac or Apple gives us for free. And we can put breakpoints in there. So we can find our VUVFS read. Okay, so there it is. So we can put a breakpoint here. And now basically what I did, can I make this bigger? Can you see this? Okay. Basically what I did, I set up some command flags here. So I'm using perf basic prof, I tell to not inline, and then I run basically the same file. So this is basically Node that I cloned, and you can actually tell, when you configure Node, you can actually tell it to generate an Xcode project. And then you can use that Xcode project to build Node and run Node. So that's what we're going to do right now. So I'm going to run our server, except I'm running it from Xcode now. Okay, so we already did it our breakpoint because we're requiring things, so let's just continue. Okay, what's going on here? Address news. Okay, so we probably got to kill something. Oh yeah, so we got to quit here. All right. Let's try it again. All right, so hit the breakpoint, just keep going. All right, so now we're listening, right? Same thing. Okay, so we're going to have to use a terminal to curl at least. Curling to our address, and boom, we hit our breakpoint in Xcode. Right? Pretty cool. So now I can go over here and I can just copy that. So I select it, I'm going to copy, and then I can go to this web app. It's on GitHub. And basically what I'm going to do here is I'm going to paste this in. It already tries to make it look a little nicer over here. And now I have to choose the file that was generated, and I have to pick the right one. So, okay, which one was generated last? Looks like either one of those. So let's go back and make sure. Okay. Always a good idea to print your PID, by the way. It's useful for a bunch of these tools. So, okay, loading that, and boom, we resolved our symbols, right? And so you don't even need to do this on the terminal if you don't want to. The disadvantage here is obviously now you cannot put source in here, right? Because the browser can't access your file system to load sources and stuff like that. So you can't do that, but everything else you can pretty much do. All right. So now let's talk a little bit how this works, right? Like what's all this symbol stuff? So basically, what's already there for a long time are debug symbols, and they're basically included with binaries that you basically compile, like C or C++ or whichever. And basically, the compiler, when it compiles your code, right, it's aware of like what kind of assembly it generates and where it puts it, and then it can basically include some information, so some other tool can then trace it back to say, okay, this block of assembly here actually maps to this line of C that you wrote. And so there are multiple tools that are available on Mac, for instance, and also on Linux, that you can use to pull these symbols back out. So For instance, here you can just run the symbols command on an executable, and it will basically give you something very similar to that map file. It will give you address, size, and then the symbol here, and then address, size, and basically tell you where actually, which line is where, and so on. You can also use dsym-util on Mac only, and that basically extracts from a dsym file, which basically inside of it has a dwarf file. These names are all really funny. So dwarf is basically a kind of debug format that they came up with, like how to write debug information. And it was created around the time when they created the ELF object format. So some people believe it's kind of a pun there. Anyway, so that's interesting. You can also use dwarf dump. So you can basically point this at any executable or any dwarf file, and it will give you these kind of attributes about every address called debugging information entries, and it will actually nest them in the way that your functions are kind of nested, and it will give you attributes for every kind of information that it has. So that's very, very powerful. And the map file that we looked at previously, the perf map file, that doesn't include all this information. That basically just maps locations. This one includes way more information. And there's also a tool called A2S. It stands for address to string or symbol. And you can basically, again, point at any executable, give it a hex address, and it will print out the actual symbol there. And now how does it relate to JIT? Well, JIT is kind of very similar, right? JIT basically is just-in-time compilation. So instead of compiling your program like at kind of a build time, JIT compiles part of your program at runtime. So, so V8, as we should know, like generates machine code from our JavaScript, right? And it does that just in time. And at that point, it can kind of give us information about symbols, right? It can, because it knows where it puts stuff, but it cannot do so beforehand, right? So we don't get the same benefit of having some executable that we can dump symbols out of. But what it can do, it can give us the symbols while it's doing the JITting, right? And one way to do that is to put that into the temp folder as a perf JIT file, or for the perf tool, right? So it's actually called .map typo. But again, that only contains simple location information. It doesn't contain any information about what are the arguments, like, or what are the, right, like, kind of how does it map back, whatever. There's another thing that V8 emits is called GDB JIT. And that's basically JIT information that's designed for debugger GDB to be consumed. And actually LLDB, if you clone the latest master and you're on Linux, you can actually get it to work to show you JavaScript in the stack trace right away by consuming this JIT information. However, that's not like working 100%, and it's always a pain to get that working. So having these tools in the meantime that I showed you is actually quite useful, because you don't have to go through this pain of spinning up a Bacon machine or something and like putting Linux on there, and somehow getting the right LLDB finally to build, and then hopefully it will work. Also, right now it's still pretty slow, because it's when it consumes the JIT information, it can kind of get pretty slow. So the JIT information generated by V8 conforms to either the ELF standard, object file standard, or to the, I'm not sure exactly how to pronounce this, macho, I guess, format, which is on OS X. So it actually looks what the architecture is and decides what kind of information to generate. And I had a fun time. I actually played with this, and you can give it a flag called a JIT full dump or something, and it dumps a bunch of ELF files into your temp folder. You should just do it just for fun and giggles. I couldn't really pull anything useful out of these ELF files, but it was kind of interesting. Temp folder full of ELFs. So this is basically the perf JIT support right here. So this is the code that makes it happen. This is taken from V8. And basically what it does, it calls OS_printf with this, this is a perf and it by PID map file, and just basically writes to that. Unfortunately, it doesn't flush it. And I guess that makes sense, because flushing would affect performance. But the thing is, it doesn't flush it if you just Control-C your process. You actually have to handle you have to handle exit it correctly or something. And also it wouldn't be available while the process is running, which is kind of annoying. So I asked if we could maybe add a flag to make V8 flush, but I haven't really gotten the useful reply. Mr. Alov told me that he's not responsible anymore. So what we can do though is we can kind of fix that, right? So there are 3 different ways how we can make this flushing happen, because it needs to happen because we need that map file. One way is you just patch V8, which I basically did. Like I didn't have to do anything during the demo, because I basically just, every time it writes to this map file, I flush the handle, and then the buffer gets flushed to disk, and now I have an updated map file. And so that's like the easiest way when you're working with this a lot. But if you don't want to run a patch V8, I created this module called flush all. All it basically does, it's a binding to FF flush null. If you call, apparently in C, if you call flush with null, it flushes all the buffers. However, I figured that, realized that it's not always working. If you flush multiple times, somehow it doesn't flush it correctly. So it's a little bit painful. So therefore, what I recommend, if you want to use that route, to put a flush route into your server while you're kind of working with this and debugging. And when you hit your breakpoint and you know that all the code has been generated that you need, at that point, well, actually before you hit your breakpoint, obviously, then call this route, and then the flush file will be flushed. Sorry, the map file will be flushed. Okay. So the other way is you could handle sig term correctly, and basically exit your process correctly, and then also the file gets flushed. So then after your server is done, at least you have the information. Okay, let me, I really only have 20 minutes? I thought I have 30 minutes.
Yeah, we have 10 minutes so you can talk and then take questions.
Okay, so I'd rather not take questions because I want to show you more cool stuff. So we can basically track a memory leak like this too. So I actually gave a talk at November at some point where I basically showed how to track memory leaks. And then here we had JavaScript again, and we couldn't see. So basically you can track memory leaks in instruments. I'm just going to say this really quickly. I may not even run through the demo. But basically you can track memory leaks in instruments. You can see if something is also leaking on the C++ end, you can actually see that. And that's sometimes an easier way to find it. And then basically these symbols here, you don't know what they are, right? But we can basically map that back. And so these symbols here, right, on the bottom, we can resolve those. And now we can see that, oh, it's called FS watcher start in FS. We can also do better. And this is the demo that I'm not showing. But basically, we can put a breakpoint in Xcode again, like we did before, right? So now we know from on the memory leak, we knew that this function is causing the leak on the C++ end. We can put a breakpoint. We can get all the stack trace, map all the symbols. We get this beautiful thing, and then we kind of see where we are actually causing the memory leak to occur, right? So that's a really quick way to find this. Previously, what we'd have to do is also go use a heap dump module, go to DevTools and kind of inspect it from the JavaScript end that way and kind of piece it together. But now actually with these tools, you can actually be a little bit more effective. And then we kind of can click on this and we kind of see watch index, and that's where our memory leak is. Pretty awesome. So now we're going to get to the big promise. Flamegraphs entirely generated on the Mac. We can do that now. So basically what we can do, use the exact same technique, because in the Flamegraphs you also have JavaScript is basically represented as assembly addresses, and that it looks really bad in the Flamegraph and it doesn't help much. But we can use the exact same technique to resolve these symbols. So this is a quick demo that I'm going to do. Okay, so what I'm going to do is I'm going to change. Actually, let me do this differently. I'm just going to run this from the terminal. So I'm just going to take an arbitrary, first of all, remove everything here. I'm just going to take an arbitrary thing I wrote, browserify markdown editor, just because it has a bunch of stuff going on. All right, and I'm going to start that up. Okay, demo gods, thank you very much. What's going on now? Okay. This may kill my slideshow, but just for the sake of. So, okay, so now we're listening on port 3000. We have a browser for Markdown editor. Unfortunately, we didn't print the process PID, so let's fix it real quick. All right. Okay, so now we're printing our process PID there. Now we can basically launch this app called Instruments. And we can say we want to do CPU counters. Where are they? Are we getting the right ones? Actually, let me cheat. I have a. Okay, I'll kill my slideshow. Oh, nice. Okay, so I think it's counters or CPU counters. So let me just. Counters. I hope that's it. I'm not entirely sure. I remember something different, but so that's it. And I can attach that to a process. And let me double check what the 1A. And it's really hard, unfortunately, to find processes in here. If anyone sees it, let me know. It used to be better searchable. Okay. There was. Where was it?
Yeah, down.
All right.
Oh, down.
That's not the right one.
Down, yeah.
That one. Awesome. Okay, cool. Thank you very much. Teamwork. So now I can attach these counters here, and I can now go to my browserify editor. Okay. So now we should actually be collecting a bunch of data. Okay. And now basically what I can do is I can expand this entire tree somehow. If it lets me anyways. Okay, so now do you see this tree, right? And you see all these unknown symbols in here, right? So what I can do now is I can say, okay, export this as a CSV file. So I'm going to export this to documents, all right? Actually, let me export it to to here, fine. Okay, so now what I can do is I can go to the Flamegraph app. So you don't need Perl anymore to generate Flamegraphs. There's an app now that just works entirely in the browser. So all I have to do is I have to choose a file that I saved. Okay, so we did something wrong. Okay, not good. But I can get a flame graph. I'm probably running out of time like crazy, but so I'm going to try to find another flame graph that I have. But let's just believe me, this works. I think I picked the wrong counters because I'm not good working under temperature. And of course, I don't have the others. So I have somewhere I have some fixtures. So I'm going to, so this would also be the same thing, instrument CSV that you would generate. So I'm going to import that. Now I have a flame graph, and that's not really, doesn't really have any JavaScript in it, unfortunately. That's already resolved. Okay, let me just try this again, real quick. So, and let me actually cheat on my slides. So what I'm going to do, do I still have time? I still have time. Okay, so I'm going to actually relaunch my slideshow to figure out what I actually was supposed to do. And then I'm going to go over here, refresh that. So, oh, I didn't include any information. That's really awesome. But I think I include information here for Mac. You go to there and you do instruments time profiler. That's what we need. Okay, awesome. So, go back to instruments, kill this, go away, new, time profiler. There it is. That's what I wanted. I knew this symbol looked, the icon looked different. Anyway, so now I'm going to call my slideshow again. Go to here. Where to go? All right, store that. Now we're going to help me find the node process again, please. Do here, here. Usually you can type node, but then it finds the first one.
Yeah, it's way down.
Way down?
Off screen. Yeah, keep
How did you see it if it's off screen?
Oh, it says Node, yeah.
This one?
Yep. Yeah, yeah.
Hopefully that's the right one.
That's it.
Yeah, awesome, cool, very good, very good. All right, so now I'm going to do the same thing. Go over to my here, refresh, collect some awesome data, go back to my instruments, stop, and then basically what I'm doing, I'm pressing Alt arrow by the way to expand all of this. And now I have this thing. Now I'm going to, okay, go back here. Now I'm going to export this. And I'm going to just save it as the same name under downloads. Ready to go. All right. All right, place. All right, go back to Flamegraph. File. Now we have to go back to downloads. Okay, do it again. Wow, I'm really not good at time pressure. So here we go. We have a flame graph with a bunch of unknown symbols, right? So that's not really that useful, but we can load a map file from temp, which got stored there, which didn't get stored there. Because, does anyone know why? Because I didn't run it with the right node. And I didn't pass it this flag. Okay, Max, you're going to have to help me one more time. Because I really want to show this. This is kind of cool. All right. What am I doing? Okay. All right, cool. So 19116, we should be able to find that. Let's just kill this guy. New one, time profiler. There it is. Okay. Now find the process.
Hit more twice.
It's sorted by PID.
Oh, it is?
Yeah.
Really?
Wait, there it is. Up a little.
This one?
No, down.
Awesome. Cool. You guys are so good. Awesome. I need you all the time. So I'm recording. Going to go to my thing again. I'm going to skip this. Refresh. Okay, cool. Save. Stop. Yeah, thank you very much. That's what I expected right now. Okay, so here, spend this guy. All right, export. So now you've seen this so many times. That's actually a good thing. So now you really know how to do this. And save. Place. Okay, and now I'm going to load this.
Drum roll, drum roll. We'll get it this time. Drum roll.
All right, load it up. Actually, let me just refresh just to be sure. Just keep doing keep doing it. I mean, nothing really gonna happen yet. You still have symbols here. I'm gonna load now. I'm gonna load now the rumble has to happen. So temp. Yay! I got a map file. What? Okay, demo fail. Officially. I have no freaking idea why this happened. Okay, well, that's how it is, demo gods. I have proof. I will make a webcast and I will show this. Sorry guys.